This is the class lesson for section 5.3, part 1, graphs of polynomial functions. We'll begin with number 16. These problems are in the practice set at the end of section 5.3. So we'll start with number 16, find the x-intercepts of the polynomial functions. And in number 16, we can factor that by grouping. So let's go ahead and do that. This is equal to, and the first two terms and the second two terms is what we'll factor. So we can factor out an x squared, and we're left with an x plus 2. And then we can factor out a negative 9 out of these last two terms, and we're left with an x plus 2 again. So these are the two common factors with these now two terms. So we can factor out, an x plus 2, and we're left with an x squared minus 9. Now notice that we have not completely factored the polynomial. We have a difference of squares here. So that is x plus 3 multiplied by x minus 3. So our x-intercepts are -2, -3, and 3. I'm just going to go ahead and highlight that answer because it's so far down on the bottom of that problem. Okay, let's look at number 22. And in number 22, what we can do here is factor out a common factor first. So I see that I can factor an x squared out of every term, and I'm left with an x to the fourth minus 3x squared minus 4. Now, this is a little bit interesting. What I would like you to do is just make sure you understand that this used to be an x squared and this used to be an x. So we will just use our method and use an x squared. We could also do this by substitution, but I think it's much easier than that. So we know that we have an x minus 4 and an x plus 1. So instead of just an x, we're going to do an x squared plus 1 and an x squared minus 4. Now I'm just going to make a little note here. If we had an x squared minus 3x minus 4, you would have x minus 4, x plus 1 with no problem. So all I'm asking is that we replace these x's with x squareds. Okay, so you could think of something like that. Okay, so now let's go ahead and talk about our zeros. But what did you notice? X squared, the sum of squares can't be factored, but the difference of squares can be. X squared minus 4 is x minus 2, x plus 2. So let's go ahead and give our x-intercepts. Note here that this term generates an x-intercept of 0. And then this term here does not generate any real zeros. And we have a 2 and a -2. See if I can go ahead and move that down here just a second here. Kind of have that written up high. Okay, so those are our zeros, or our x-intercepts. And you can write them as points as well. Intercepts are typically numbers, but they're also points. Okay, so let's go ahead and go to number 30. We're going to talk about the zeros and give the multiplicity of each. So let's go ahead and first look at this 0. We have a 0 of -2, and that has multiplicity 3 due to this degree 3 term. Okay, and then we also have another 0 of 3, and that has multiplicity 2. Okay, so we have a cubic and we have a quadratic term here. Okay, Let's go ahead and look at number 32. Don't forget about these. X cubed would be a 0 of 0 with multiplicity 3. We have a 0 of 1 with multiplicity 3. And we have a 0 of negative 2 with multiplicity 1. Okay? Okay. Okay, let's go ahead and look at number 36. Now there's going to take some factoring in some of these, so we're going to have to make sure that we practice those. I gave a little bit of extra room here. So we do need to factor this. So I'm going to have an x, and of course this first trinomial will be factored into two binomial factors, and this second one. So we will have the x is there, and then we will have this trinomial and this trinomial. Now, if you can see here, these are actually perfect square trinomials. So actually setting this up like this probably wasn't a good idea. Usually isn't a good idea. But you can see that that 4x squared is a perfect square and 9 is a perfect square. So we have 2x and 3 if we take their square roots. Now, if you multiply these together, 6x, and double it, you get this 12, and we need a negative, of course. So that's how we know that we have a perfect square trinomial. If you need to pause the video and think about that a minute, that's fine. Square root and another perfect square, so we have an x plus 4. If you multiply those together and double it, x times 4 is 4x, you get an 8x. So we know that this is also a perfect square trinomial, okay? So probably didn't need this much room. So now let's go ahead and find our zeros. We'll have x equal to 0, and this is just multiplicity 1. We have another 0. Whoops, I probably should have just put, yeah. And here we have a positive 3/2. Let's go ahead and do that down here. 2x minus 3 is equal to 0. 2x equals 3. X is equal to 3/2. That's where we got that one. And that has multiplicity 2. And then we have one last 0. And that is x plus 4 all squared. So we have a negative 4. And that has multiplicity 2. Okay, let's go ahead and look at number 40. And in number 40, we first can see that we could factor out another x out of this term. You see it has a common factor of x. So we're going to, I'll just put the x there initially. X squared minus 4x plus 4. So this actually becomes 2x to the 5th. And now we can factor this x minus 2 all squared. This right here is another perfect square trinomial. X squared, square root is x. 4, square root of 2. 2 times x is 2. Multiply that by 2 and you get a 4. So this is really x minus 2 multiplied by x minus 2. Okay, so now let's go ahead with our zeros. We have a 0 of 0, and that has multiplicity 5. And we have one more 0 of 2, and it has multiplicity 2. Okay? Let's go ahead and take a look at these graphs. In number 53, we want to use the graph to identify the zeros and the multiplicity. So these are, once you get the hang of these, I think you'll really like these. In 53, I like to start from left to right. So I'm just going to put 53 here and then maybe just work. So I see negative 4, negative 2, 1, and 3. Okay? So it looks almost linear. When it crosses the x-axis, there's no stall, there's no flattening out. So our zeros would be -4, -2, 1, and 3. And they all have multiplicity of 1. Okay? Because we just cross through that x-axis without any flattening out. Okay? Let's go ahead and I'll change colors alternately. We have -4, -2, and 3. And notice what happens at 3. It touched the x-axis and moved away without a flattening out. So that will be a multiplicity 2. So when we cross the x-axis, we have odd multiplicity. And we touch and move away, or you could say bounce, we have even multiplicity. Why don't I say bounce? I think that's probably, you may hear me say touch and move away, but bounce at x-axis, we have an even multiplicity. Okay, so let's, this is number 54. So we have -4, -2, and 3. These have multiplicity 1, and 3 has multiplicity 2. Okay, look at 55. So in 55, I'll go ahead and switch colors again. How about blue this time? -2, that is a multiplicity of 2, and 3, that is a multiplicity of 2 as well. So in number 5, our 0, we have a 0 at -2, with multiplicity 2, and at a +3 with multiplicity 2. Okay, I want you to note the difference between crossing the x-axis in 56 and crossing and flattening out. So this increases the degree when you see that flattening out, okay? So I think the last one I'll use is maybe this pink color. And in number 56, see if I can get a little bit thicker. And in number 56, ooh, that's awful thick. Okay, we'll give that a try. And our zeros, and we have a -3 and a -2. Both of those have multiplicity 1. But as you can see here, we do cross the x-axis at x equal to 1. But we can't give it multiplicity 1 because it flattens out. So we have to go to the next odd number, and that would be multiplicity of 3. And that concludes this first part of section 5.